Hello. Today we are going to start a new course which is Internet of Thing, and we are going to learn Introduction to Internet of Thing. In Module 1 we have these topics: definition and brief history of IoT, advantages and disadvantages of IoT, key concepts, sensors, actuators, connectivity, data, analytics, and applications. IoT stands for the Internet of Things, which refers to the interconnectedness of various physical devices and objects through the Internet. These devices can communicate with each other and with humans, collect and share data, and perform various tasks automatically. The concept of IoT has been around since the early 2000s, but it became more popular and widespread with the advancement of wireless technologies and the proliferation of smart devices. The term Internet of Things was first coined by Kevin Ashton in 1999 while working for Procter & Gamble to describe the network of interconnected devices that could track and manage inventory in real time. Today, IoT has numerous applications in various industries such as healthcare, transportation, manufacturing, and agriculture, among others. It is estimated that there will be over 75 billion connected devices worldwide by 2025, with IoT generating significant economic and social benefits. Advantages of IoT. 1. Improved efficiency. IoT can improve efficiency by automating processes, reducing errors, and optimizing resource utilization. This can lead to cost savings and increase productivity. 2. Enhance customer experience. IoT devices can enable companies to personalize their products and services based on customer preferences and behavior, leading to higher customer satisfaction and loyalty. 3. Data collection and analysis. IoT devices can collect vast amounts of data, which can be used for analytics and insights to improve business operations and decision-making. 4. Remote monitoring and control. IoT devices can enable remote monitoring and control of various systems, such as home appliances, industrial equipment, and vehicles, leading to improved safety and convenience. Disadvantages of IoT. 1. Security risks. IoT devices can be vulnerable to cyber attacks and hacking, leading to data breaches and privacy violations. 2. Compatibility and interoperability issues. IoT devices from different manufacturers may not be compatible with each other, leading to interoperability issues and complexity. 3. Cost and complexity. Implementing and maintaining IoT systems can be expensive and complex, requiring specialized skills and infrastructure. 4. Ethical and social implications. IoT raises ethical and social implications, such as data privacy, surveillance, and employment displacement, which need to be addressed. Sensors. Sensors are devices that can detect and measure physical or environmental variables, such as temperature, pressure, motion, or light. Sensors are often used in IoT devices to collect data and trigger actions based on changes in the environment. Actuators. Actuators are devices that can receive commands and perform actions such as turning on a motor, opening a valve, or releasing a drug. Actuators are often used in IoT devices to control and manipulate physical systems based on data and analytics. Connectivity. Connectivity refers to the ability of IoT devices to communicate with each other and with external systems through wireless or wired networks. Connectivity enables data exchange, remote control, and coordination among devices. Data. Data refers to the information collected by sensors or other sources in the IoT system, such as user inputs or environmental factors. Data can be structured or unstructured and can be processed, stored, and analyzed to extract insights and drive decision-making. Analytics. Analytics refers to the process of applying mathematical and statistical methods to data to identify patterns, relationships, and trends. Analytics can be used to extract insights, make predictions, and optimize operations in IoT systems. Applications. Applications refer to the specific use cases and scenarios where IoT technology is applied, such as smart homes, industrial automation, healthcare monitoring, or environmental sensing. Applications can vary in complexity and requirements and can involve different types of devices, sensors, connectivity, data, and analytics. Thank you for watching us. Stay tuned for next part.